Hi, I'm Alex Huang, and today I'm going to introduce my visualization. And in this product, I use Python Matplotlib to visualize the country incomes, the relationship between country incomes and secondary education enrollment since the 1960s. And I get this inspiration from the third exam product, which analyzed the immigration to the US as a growing tree. And first of all, I'm going to introduce the overall structure of my code. So the first part of my code is data procession, where I first import the data and choose the specific entries that I'm interested in, which are the country incomes. And I also correlate the two data, which are two different lists, the income population and income uh, enrollment. And after that, I get the number of students enrolled in secondary education. And then I sum them up, sum up the 10 years of data to get the decade, the number of students going to high secondary school by country by decade. And after that, uh, it goes right into my graphing part where I first calculate the number of dots in each decade and in each country income group. Then I set the color of each dot and using random process to generate the polar coordinate of each dot. Then I set the title of the graph, the legend, the axis, and yeah, of the graph. Then I just plot it, and there are some special features in this particular product. One of them is representation using a growing tree, because first of all, it's very interesting and creative, and it also corresponds to the first subjective success criterion. And there's actually a metaphorical or symbolic meaning in my design, because children and students are children and students are kind of like the future of the world, and the education system, as they educate more people, it's kind of like it will expand and grow. So I think it's actually a proper appropriate metaphor for the education system as a growing tree. And the second uh feature that I'm very proud of is the use of polar coordinate and random numbers in my project. So each dot is characterized by a polar coordinate, which consists of a radius and the argument, which is the angle to the x-axis, which makes it much easier for me to allocate the position. And also, the position of each dot is generated by Gaussian integers, followed by Gaussian distribution. The reason why I chose Gaussian distribution is that it's like, because the growth of any organism like kind of follows the Gaussian distribution, a Gaussian profile. So the random process actually better mimics the growth of a tree. Yeah. And I also perform a lot of skills, but I will talk about my research skill in particular. First of all, in my data research, I collected a variety of credible data from many different sources. I also cross-referenced some of the data sources to ensure the accuracy and the credibility. And also, I did some research on existing products, the third examined product in particular, where I read the original article of it, and it's actually the basis of the outline for a program. And I get the idea of using the polar coordinate instead of Cartesian coordinate from that paper. I also learned some basic Python skills, how to use Python functions, how to use for loops, and I also learned how to use polar scatter plots, legends, titles, colors, and generate different types of random numbers in Matplotlib and NumPy, which is also very cool. However, there's still some improvements can be done. For example, I can do some visualization with a variety of different relationships. For example, secondary education enrollment versus geography, household income, ethnicity, even gender. And also visualization can also not just limited to secondary education. I can also do primary and tertiary education, or even further just to combine all three to come up with a visualization. These are all cool ideas. And another possible improvements can be done is to make like a annotation under like a graph here, just to because I already have an annotation in GitHub, but maybe that's not very convenient for the audience. So if I make it here, it will be much easier for the audience to read while reading a graph. Yeah, that's it. Thank you for watching.